Hello, everyone. My name is Hugo Dorado. I'm a researcher from the Biodiversity Seattle Alliance. And for this presentation, we're going to talk about attribute or feature selection. This material is part of the course, the Foundation of Information Analysis and Data Mining in Agriculture, developed by the CIAT and Biodiversity Alliance, Illinois University, CIMMYT, and the CCAPS project. Very well. After removing all the variables that are not important in the dataset cleaning process, there are some criteria that are important to do second selection, where we try and keep the most important and informative variables. Some of the reasons why it's important to have this step of attribute selection before doing our final model is that it's important to remove and reduce the effects of unimportant variables. The fact of having more variables that are necessary could affect the model from different perspectives. And sometimes it's also necessary to try and reduce the complexity that we have in our data matrix. We have if we have a matrix with many variables and some of them do not give enough information, but we try and use a model nevertheless, it'll probably be a lot harder to find those relationships and those patterns that we are interested in. The more information and noises, it's going to be harder. Uh, so if this noise is there, it'll negatively impact the model. So what can happen if we keep those variables is that we're going to have lower performance. And if we remove them, we'll improve that predictive performance. And also, the less variables that we have, it's going to be easier to interpret the results of the model. And it can even increase the speed. This is good to train the model and generate a final result. So due to this different aspect, it's important to do an attribute selection. There are other names and how we can define this concept of attribute selection. It's also known as variable selection, characteristic selection, or feature selection. The main purpose of this is to use a initial variable set and try to identify a subset of those variables that is important, that's enough for trying to achieve our purpose. So we try to remove all those variables that in the end aren't helping significantly with this objective in mind. So this is the main objective. There are multiple applications in this topic, from text mining, where usually there's information about different texts, different paragraphs, and what we want to do is to extract variables that are important. The variables would be words in text mining. So it's about identifying those important words to try and classify texts that are similar, that talk about similar topics, or to try and predict what's being talked, what's the core topic in each one of them. So there are some that are more important than others, and what attribute selection or feature selection does is try to identify those variables that are important and to remove the ones that are not going to help us reach the goal. In genetics, there are also many sequences of information with data from different genes, and not all of them help to attain the objective that we're planning on with that information. So attribute selection or feature selection helps us to choose those that aren't so relevant to keep. And there are multiple applications regarding what can be done. And the idea is that since these are information matrices that are so large, trying to reduce as much as you can that amount of information so it's easier to execute the model. And in the industry, this is more associated to the cost to measure certain variables. Probably in our first exercise, many more variables were collected than necessary, and those variables could be very costly. it can be very costly to measure them. So as we identify variables that are not going to help us with good information for our model, um, it'd be best to try not include them in the next measurement, because this is going to increase the costs. There are three concepts that are key in this topic of feature selection or attribute selection. The first one is an attribute that is irrelevant, that can be considered a variable that does not affect the performance of the model in any way. For example, a variable that has no variability, that through the different observation it maintains its same value, but probably it's not going to help to the predictive capabilities on the model that we are building. So in this case, it would be irrelevant variable. And there's also redundant variables. These do not help with any additional information in the model. This could be the correlated variables. Let's say that we have one, two, or three more variables that are correlated. So probably just keeping one of them would be enough. So it'd be better just to keep one, or try to um, keep something that allows us to summarize that information in just one variable. In this case, it would be redundant. And finally, we can consider an attribute that's relevant if it does not comply with this criterion, that it's either irrelevant or redundant. This is an example of attribute selection or feature selection. Let's suppose that we have three attributes or three variables. We have an M classifier, and we have to predict T. So this is an attribute selection where we include the three A, B, C, A, B, A, C, and all possible combinations. And what we can do here is to assess the performance after selecting those attributes with the classification model. In this case will be the M classification. So if we do not select any attribute, we would have an 85.1% of certainty. If I assess that if I include all the attributes, I'm going to have a 98% of accuracy or performance. But I'd have the same result with A and C. So in these two, I would prefer this one, because this means I'm going to have to do a lower effort on collecting variables, and it's a lot easier for the model to analyze two attributes instead of three. But I could also have another candidate here, and this is due to simplicity. There are some times where I could decide sacrificing a little performance just to make a simpler model. So this also depends on the criterion of the people that's assessing the data. If you prefer higher simplicity, or to increase the performance in just a small proportion, that's what you have to do during the feature selection or attribute selection. And to do this, it's important to take into account the following. First, to set an input variables that are predictors, all of the ones that are available. A response variable, in this case, what we are seeing in the attribute selection is more directed to predictive models, to supervised models. And there's also a performance criteria for supervised models that we're not going to dive in here, but it has the same principle. If you're grouping, we have to try and identify those variables that help to that data set. In this case, we are identifying variables that help on explaining or predicting that response variable that we have, that we're interested in. It's important to define performance if we're going to assess the model with exactitude, or the RMSE in a regression model. It's important to take this into account, because in the end, this is what will allow us to assess the quality of the attributes that we choose in the end. It's also important to define the predictive model. It's not always required. We can use other models to select attributes that are based on information. We're going to see this afterwards. To carry out an independent assessment of each predictor based on the response, but it does not use the predictive model. But normally, it's important to define it previously. Even at the end, with our subset of attributes, we should try and assess its effectiveness. It's also important to define the attribute selection method. This is something that we're going to see in the next presentation. We'll see that there are three different ways to do this attribute selection. And it's also important to define the stop criterion. Sometimes you have the objective to reach an exact performance. Like for example, like in last case, we wanted to reach a percentage for classification of 97%. So we tried different solutions until we reached that value of effectiveness. That's a way to do it. Or sometimes it can be declared based on the number of attributes. So in my model, I want to have at most 2 attributes or 3 attributes. That's very little. If we have 50 variables, we can fix it in 15 attributes. So what we do is to use algorithms that help us to explore what are the best 15 until we reach that number. And that's when you stop. It's also important to use a search strategy. And what this suggests is what our solutions are going to be tested. So let's say that we have 50 variables. You can decide that you're going to uh, have the solution with 7, 15, 30, then 1, 9, 24, 50, and so on and so forth with each one of them until you choose the one that complies with the criterion that we define. It's not necessary to always try all possible solutions because sometimes it can require a lot of processing power. Trying all combinations with 1 or with 2 or with 3 and so on and so forth until you reach 50. Instead of this, you can do a test that's very complex at a processing level. In a normal computer, it'll take probably days trying to combine all the possible variables to choose the best subset. So there's a function of criterion that allows us to guide and assess that search with very few interaction. An interaction would be a subset of variables that are tested to see their quality. So this helps us to identify in very few interaction how we can find that solution that's effective in a faster fashion. So once the criterion is defined and the subset of variables that are candidates are defined, then we assess the subset or the possible subsets. These are assessed based on the metrics that we establish. So this subset is assessed based on the function, and based on this, we generate our quality measure for the model. And in the end, if we establish a stop criteria like this one, it's 0.95, then we can say we're going to keep the solution, which is the one that among the possible subsets was the one that reached that stop criterion of 0.95. Or over 0.95. Or we can also say that the maximum that we want is to have 2 variables. So with 2 variables, we reach a 0.76. These are the 2 different ways, and the researcher decides which one to use. Key points for this presentation. The first one is that we were able to define the concept of feature selection as a method that seeks to identify a subset of input variables that are candidates to be part of a model. And with this, we would like to reduce the complexity that we can have and maintain or improve the performance based on removing variables that are redundant or irrelevant. And with this update that we do in this subset of variables that we're going to include in the model, what we want to achieve with this is to either maintain or to improve the performance. And apart from this, we are able to identify that in order to do the attribute selection, it's important to define a method that's going to be used for executing this process. And it's also important to define a criterion for stopping, a stop criterion. Having said this, we just finished this presentation. I hope that you liked it. And the next presentation is going to be done on the selection method for the attributes, and afterwards we're going to have the practical part. So see you in the next presentation.